Hey everyone, welcome to Debugging. If you ever struggled with debugging your code, today's video is just for you. I'll walk through the powerful debugging tools in Chrome step by step to make your development process smoother and faster. This video contains everything you will need in order to understand how debugging in the browser works. Debugging is basically the process of finding and fixing errors within a script. I will be using Chrome Developer Tools for this video because it has enough features on the most other browsers have. Now open the source panel and the Developer Tools with the right click anywhere on the page and select Inspect or simply press Ctrl Shift I for the Windows or press Command Option I for Mac. Navigate to the source panel. Now this simple code right here is what I'll try to debug. If you don't see the page tab, upon opening the source panel, then click on this toggle button, which opens the tab with files. After that, let's click the index.js file. And here's what going to show the source panel. Has three sections. First one is file navigator, and that lists the HTML, CSS, JavaScript, and the other files including images that are attached to the page. And Chrome extensions also appear here. Second one is the code editor pane that shows the source code, and the third one is a JavaScript debugging pane, which is for debugging. Now I'll click on the same toggle button again to hide the file navigator pane and give the code some space. Now next I'll quickly explain the code we are going to debug. In the index.html, I have implemented a simple counter app in HTML and JavaScript, allowing the users to increment, decrement, or reset a numerical counter displayed on the web page. The counter value is displayed in a paragraph element that is a p tag and has three buttons: increment, decrement, and reset. And JavaScript file is inserted to using script source. The app features a display element p tag with the ID count that shows the current count on three buttons: increment, decrement, and reset. To interact with the counter, the count variable is initialized to 0, holds the current count value. Event listeners added to the buttons to trigger the respective functions when clicked. The increment function adds 1 to the count, the decrement function subtracts 1, and the reset function is meant to reset the count to 0. However, an intentional bug sets the count as string 0, leading to the potential type issues. The update count function is responsible for updating the display with the current count value and includes a safeguard to check if the count is not a number, that is, it is non count. If a non-numeric value is detected, the count is reset to 0 to prevent errors. Additionally, console.log, the statement provides insights into the value of count during the debugging, making it easier to track issues like incorrect data type or unexpected behavior. So now let's talk about breakpoints in the index.js file of the source panel. Click at line number 18 and line number 23. Now I have two breakpoints. So what is breakpoint? A breakpoint is a point of code where the debugger will automatically pause the JavaScript execution, and while the code is paused, we can examine current variable, execute commands in the console, and so on. In other words, we can debug it. In the right panel, we can always find the list of all breakpoints. We can have set in any file that useful when we have many breakpoints in various files. This allows us to quickly jump to the breakpoint in the code by clicking on it. In the right panel, temporarily disable the breakpoint by unchecking it. Remove the breakpoint, right clicking and selecting remove. Now let's activate the debugger after setting up breakpoints. Basically, we want the debugger to pause on our specified breakpoint in order to allow us to view the state of our code at the current breakpoint. By state of our code, I mean the state of our local or global variables, whether they have been assigned or not, and if what they have been assigned to state of our code also means the function parameter and basically everything you see in the code before the breakpoint. The breakpoint allows us to pause our application at any moment and look around the state of our application. In this example, the breakpoint is set within decrement and reset. So the easiest way to activate debugger after we have set the breakpoint is to click on the increment button. Since this will invoke the increment function and debugger will go within the contents of the function. Now as the breakpoint is Set the execution process at the 18th line. Open the informational drop downs to write labeled with arrows and allows you to examine the current code state. Let's talk about watch now. It's basically shows current values for any expression. You can click the plus icon and input an expression. The debugger will show its value automatically, recalculating it in the process of execution. So basically, if I want to watch a variable text, then I can simply click the plus icon and input text. So now, if I refresh it, you can see the text is not available initially since I haven't invoked the increment function. But once I click on the increment button to restart the debugger, you can see the watch the variable along with its value, which is 2, because the code passes in line 18. Due to the breakpoint, we added the value of the variable count is assigned to updated by the time the debugger reaches the line 18. So the watch will now show the current value of the variable as it is added. Now next, let's understand the call stack shows the next call sign. So basically it shows what function is currently being run and what function are called from within that function at the current moment. The debugger is inside increment function call, which is called by click event listener. After clicking on the button, that's why the call stack has only increment function at that moment, because the breakpoint has passed the execution of debugger at line 18. It hasn't yet gone within the increment function. So call stack only has increment at that moment. If you click on the stack item increment, in this case the debugger jumps to the corresponding code and all its variable can be examined as well. So if there were multiple functions in the call stack here, then clicking on the function would be have taken the debugger to its corresponding code and also displayed the values of its variable. Next drop down is scope. When you pass down the line of the code, the scope pin shows you what local and global variables are currently defined along with the value of the each variable. When you are not passed on the line of the code, the scope pane is empty. Local shows local function variable. You can also see the values highlighted right over the source in our example. The local has the this keyword because it's a normal function and that this keyword always points to the object the function and then click in this case is attached to, so that this keyword is the button element itself. Now the script will always include the let and const variable declared outside the function. Since here I have the variables count element, decrement button, increment button, reset button declared with a const keyword outside the function, they get added within script in the scope. When you declare a variable using var on the top level I mean not inside the function, it automatically becomes a global variable. So in the browser you can access it as a property of window. It's different with variable declared using let and console. They don't become a global variable. You can access them in another script head, but you can't access them as properties of window. So that's why here let and const even they seem to be declared globally or in global variables, and global scope has a global variable. So basically the variables that are out of any function and do not have let or const. For example, if I declare a variable a and assign it a value of hello, then I refresh and click the increment button again. You can see the global scope. How as a variable a with the value hello. So variables declared with var keyword outside any function are globally declared and come within the global scope. Now the last step is trace the execution. Basically, we need to trace the script from one breakpoint to another. We can trace the execution of the script by clicking on the buttons at the top of the right panel or by clicking this icon. Here, basic pause and debugger firstly, I'll click on this icon named resume. It resumes the execution. When the debugger is paused after hitting the breakpoint, the resume can be used to continue the execution into the next line. If there are no additional breakpoint, then the execution just continues and the debugger loses control. Now I'll reset all debug up to help you understand better, and then click on resume. Once here's what we can see after they click on it, the execution has resumed another breakpoint. Insert the reset function and pause there. Take a look at the call stack at right. It has increased by one more call. We are inside the update count function. Now I'll reset everything and explain other icons present here. The first one is step, which means to run the next command. It will basically the next statement. If I click it now, it will go to the next line, which is declaration of the content variable. Clicking it this again and again will step through all script statement one by one, and you can see after the update count function is complete, the debugger goes to the last line of the update count function, and the call stack doesn't have the update count anymore because we stepped through update count function. Next, understand the step over icon. This icon will run the next command but won't go into the function. It's similarly previous to step command but behaves differently if the next statement is a function call that we created. So step over is good if we are not interested to see what happens inside the function call. Next, understand the step into icon that similarly to step but behaves differently in case of the asynchronous function calls. Understand step command ignores the async action such as set timeout that executes later, whereas step into goes into the code waiting for them if necessary. Next, understand the step out icon. The step out icon continues the execution till the end of the current function. So basically continues the execution and stop at the very last line of the current function. So it basically skips the remaining content of the function and continues the execution till the end of the current function. Now the next icon is enable or disable all breakpoints. That button does not move the execution, just activate or deactivate all breakpoints. So that's all for the video. The amount of information shared in this video should be enough to get started with the debugging in the browser. Thanks for watching. If you enjoyed this video, don't forget to hit the like button and subscribe for more apps and content. See you in the next one.